0.5 times 3 times 4 times sine of what? 30.
That's the same thing. Oh,
no. No, it's not the same. What do you end up with? 3. That's pretty cool. Is it just kind of nice that it got to a nice answer?
Yeah.
Is that kind of random? It's kind of random. It's also, I picked an angle value that would play nicely with that formula. So the angle answer was 3. Guys, I'm not asking you to understand what sine is. I'm not asking you to understand where it comes from. I'm just asking you at this point to understand where the button is on your calculator. It's on your calculator, S-I-N. And make sure your mode you're in, what mode? Do you remember? Degree mode, okay? Not radian. Not radian, in degree mode. So, I just told you the area of a triangle is 1/2 AB sine of the internal angle. See if you can use that information to generate a formula for a regular n-gon, where n is the number of sides and s is the side length. Area is 1/2 AB sine of theta. So the formula I want you to come up with only has n and s in it. Only has n and s in it. See if you can come up with an area formula for the polygon, a regular n-gon with n sides and s being the side length and n being the number of sides. So let's look at a big n-gon. So let's say there's all these sides that are going to be here. So let's say the side here, side, side, side. This is an n-gon. So all the sides have the same length. Okay. So it'll go to the center and you'll have these triangles. There'll be lots of them, right? How many are there going to be? N triangles. So if you found the area of one, would you be done?
Yeah.
Because you could multiply it by n. You know that this is s. Can someone tell me what this, raise your hand and I'll call on you. What's that theta value? What does the theta equal, the angle measure right there? Anybody have it? Yeah.
360 divided by.
Okay, so you have 360. Just not wanting to write there. 360 divided by n. Exactly. So 360 n. Now, I do agree that it's an isosceles triangle. That is correct. You need a side length there, but the side length needs to be in terms of what?
S.
S. The side length needs to be in terms of S. So let me just draw this differently. You have a triangle, an isosceles triangle. This angle is 360 over what? N. And this base is S. You need what? If you want to find the area of this triangle, what would you need? There's two ways to go about this. If you didn't have that 1/2 AB sine C, to find, if you didn't have that, how would you find the area of a triangle? What was the first way we found? What? 1/2 base times height. Is that correct? 1/2 base times height. So theoretically, maybe we would want to look at the height of this triangle. Okay, so let's do 1/2 our height here. So that's h. And what do we know the base of each of these triangles? There's two triangles right there. S over 2. And this thing is h right here, correct? What could we find based on h and that s over 2? What could we do next? Yeah. We could find one of those side lengths, right, using the what theorem? Pythagorean theorem. You could have h squared plus s over 2 squared is equal to, what do we want to call this length? L is equal to L squared. So what does L squared is equal to? Well, we have that, sorry. So what is L equal to? The square root of h squared plus s over. So what's the problem here? We have the theta value, and that's great, but we still have what? What's the problem? H is a problem. What do we want h in terms of? Or s and what? We want h in terms of what? Okay, we're looking for a formula that's entirely in terms of s and n, correct? We want something that's entirely in terms of s, and if needed, and what? If needed, n. So I'm going to draw a couple points on this. I'm going to call this, yeah, let's right there, right there, right there, and right there. I'm going to connect these right here. I'm going to connect them. I'm going to tell you that that side length is A, that's A, that's A, and that's A. Let's call that B. Let's call this B, B. We'll call this C, 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 and C. This whole thing, and also I'm going to tell you that this is 90 degrees right here. What's the side length of the entire thing? Of one side of the square? What? What's this one side has a length of what? What? B plus A. One is A plus B. Do you agree with that? Okay, you agree with that. That's nice. If you wanted to find the area, if that's one side length and that's a square, what's the area of a square? What? No, that's the perimeter.
A plus B squared.
A plus B squared is the area. Do you agree with that? Okay, this is 90, right? Do you agree with that? Okay, well, I told you that that's 90, right? So do you agree that this angle and this angle have to add up to 90 degrees?
Yep.
So therefore, this angle and this, oh, those are the same angles, right? So what is this angle 90 degrees? Yeah, it is. You kind of get why that has to be 90 degrees? The other two are 90? Okay, so there's a square in the center. What's the, okay, because okay. So this and this, that those have to be 90 when they add together. The internal angles of a triangle are, when you add them together, 180. I told you that this is 90. What's 180 minus 90? What is 180 minus 90? 90. Okay. So what do these two angles have to add up to? Do you agree that these four triangles are all the same? Yes, they are all the same. So therefore, this angle right here and this angle right there have to be congruent. Do you agree? And therefore, this angle and this angle have to be congruent. So therefore, this angle plus this angle has to be 90. And you know that a straight line has an angle of what? 180. Right. Okay, so do you agree that this is a square right here? What's the area of that center square? Do you agree with that? What's the area of this triangle right here? 1/2 base times height. Do you agree that that triangle is 1/2 base times height? How many of those are there? 1/2 base times height, 1/2 base times height, 1/2 base times 4 of them. Okay, so do you agree that triangle, so that square, the whole big square is made up of those 5 pieces? That's a tessellation of sorts, right? That's nice. Okay, so what's another way to write this area? C squared plus 4 times what? 1/2 AB. Do we have a different way to write the area? Yeah. So if we have 2 ways to write the area, they both have to be equal. So we now know that A plus B squared has to be equal to C squared plus, do you agree with this? That's nice. Let's multiply this out. What's A plus B quantity squared? A squared plus 2AB plus B squared equals C squared plus 2AB. What cancels? I'll go back in a second. What cancels? And what are you left with? As a side note, Tyler, A plus B times A plus B. You FOIL it out. A times A is A squared plus AB plus AB plus equals A squared plus 2AB plus B squared. So what did we just prove? We just proved the Pythagorean theorem. Are there other methods? What? Are there many other methods? What do you think? Yeah, there are lots of different ways to prove the Pythagorean theorem. This is one of them. This is one of them.